Thank you. Thank you. Okay. So, hello guys. For today, we will practice some questions for graphing linear functions and quadratic functions. And the knowledge is the thing that you basically learn from previous class. Today is just a practice. And then next week, we will get through some new things. And then, yeah, let's start from Roger. Roger, you can choose 5 questions from the slides, and then Ron, you can choose 5 questions from the quadratic one. Go ahead.
Okay, so I'll choose 5 questions from this slide. So first we choose this one. And then this one. And then this one. This one and th and this one. So first we look at the first one. Um, we look at the first one. It is this is it is not in a pretty normal form, but we can still get something from this. So we can first simplify this to 2x plus 10 minus 7 equals 3x minus 6. And then we put x and all the other constants on each side. So this becomes 10 plus 6 minus 7 equals x. So x equals to 9. Is there some problem with your screen share? Oh, never mind. And then we know x. We know the equation is x equals to 9. We can since in this equation there is no y, so there is no change on the y. So the answer is obvious. Um, we draw the x-axis and y-axis. Since there is no change in y, it will be a flat horizontal line. It should be flat, but I cannot draw something flat. And this point should be 0, 9. And this is, wait a minute. Uh, so actually I made a mistake. Actually there is no change in x instead of y. Um, so no matter what the y is, the x is always 9. So we find the point where we can find the easiest point we can find like x equals to 9, which is 9, 0. So we draw a vertical line that is straight since no matter what value y is, x is always 9. But keep in mind that this equation is actually not a function because like it is because a function in a function only one x value only corresponds to one y value, and this equation in this equation one x value can correspond to infinite y values. So we have solved this problem, and we look at the next problem. This one, um, this one seems to be pretty simple. So in a normal sense, we need to change the sign at here. So we change it to uh, y equals to negative x over 3 plus 2 over 3. So we know, so we set, if we set x to 0, then we can eliminate this thing, and we can see when x equals 0, y equals to 2/3. So we get the first point 0, 2/3, and then we can draw it on the graph, and we know there is a 0, 2/3. And then in a normal sense, I would do like set y equals 0. That is to find the intersection on the intercept on the x-axis. So 0 equals x over 3 negative, and plus 2/3. And we move this thing to this side. So x over 3 equals 2/3, and we multiply both sides with the 3, it becomes x equals 2. So we find the x-intercept, which is 2, 0. And finally, we can draw out this line, um, which is x equals negative x over 3 plus 2 over 3. So we've done this question. And then we move on to the next question, the question S. Um, question S, which is this question. This question isn't in a normal form, so um, so we can change it to the normal form. First, we definitely can do, we move the x and the -1 to the right. We definitely can do so, and the equation becomes 11 minus 2x, but this is not efficient enough. This is not efficient enough. So in another sense, we can change it to the dot form. I don't know what you call it, but I will call it a dot form. So it becomes y minus 1 and 10 minus 2x. Um, so here we can change this to -2 uh, x minus 5 equals to y minus 1. So in this form, we can see this is actually the k. And this is, and here, they indicate the point um, 5, 1. So, so we plot uh, 5, 1, 5, 1 here. And then we can then move this to the right. We can see it is y equals um, 11 minus 2x. So here we can see another point here is 0, 0, 11, and we connect the 2 points. And this is the graph of question S. Um, so if you do this question using this method, um, you don't have to get in touch with things like fractions or decimals. Um, so we move on to question W. Question W is a little special because it involves the calculation of absolute value. So we review the absolute value. Absolute value means that if you have a absolute x, if it is always positive. So if it's -3, If it's -3, it is 3. If it's 3, it's still 3. So we once we record this, we can do this problem. So first, um, use the most basic thing we know, use the basic knowledge. We know that the +2 can be removed at first because it is just moving the whole function up for 2 units. So we look at y equals uh, absolute 2x, but actually, and actually we can represent this using a segmented function, which means we have a different function at different domain. So since this is an absolute value, when 2x is larger or equals to 0, uh, y equals 2x. So this is actually x larger or equals to 0. And for another domain, when 2x is less than 0, that is x is less than 0, um, y equals -2x. Um, so we can draw the two functions. First, the 2x here is the 2x, but we need to cut the 2x um, here because we have our domain here. And another function, another segment here is -2x, which is like this. But we need to cut the function here because here it only applies to when it only applies when x is negative. So in this way, we can actually draw the y equals absolute 2x, and we only need to, and for the final answer, we only need to move up this function for 2 units. So it's basically looks like this, the dark blue one. And here is 2. The distance here is 2. Um, so we finished this problem. And we come to the last one. Um, and then we come to the last one. Uh, we come to the last one. This is pretty complicated. It seems really complicated, but uh, is there some problem with your screen sharing, or it's just my problem?
When I well, go ahead. I will tell you later.
Okay. So we do the same thing as before. Because it seems too complicated, we'll peel it, like peeling fruit. So we remove this at first, and then um, we can tackle with x equals -2 uh 4x minus 8. And as we know before, we actually can see that a function can be moved to the left or the right by adding to the inside of x. So we can represent this 4x minus 8 as this thing. So y equals -2, this thing. And we can do it further uh, because we have our basic math skills. Um, if we multiply a positive number with like we multiply a positive or negative number, we don't change their sign. So um, so actually we can further do it as y equals -8 x minus 2. So finally we can see this x is moved to the right since this is a minus sign. So we need to do it as y equals negative 8 x. So finally we can graph it. Like before, I will not explain the same thing twice, so I'll just graph it. Like this. This is how negative 8 absolute x looks like, and then we'll move it back. So since it is moved to the left, moved to the right, for 2 units, so we move it to the right for 2 units, and we then move it up for 3 units, like this. So here is this point. So we graph it again, and this is how this function looks like. So we finished all the 5 questions.
Okay, thank you. Okay, let's do some quadratic graphing. Hope you guys remember something there. And yeah, go ahead, run.
I can do it if you want.
Yeah, just choose 5 random like question in this slide and then just explain, you know.
Wait, we don't do the 7 and 8 sides?
No, just do this one because we have the previous lesson already.
Okay. So we need to graph those functions, right? And one moment. So should I choose 5 questions? Okay. Okay, so shall we give them some time to read the question, or I just going to start?
Yeah, you can start like for 4 question and leave the last one.
Okay. So for the first question, that's the simplest quadratic equation. That's the most standard form, which is something like this. Something like this. That's the standard form. And I think we should be all good about that. And for the second question, we're gonna graph that equation, right? Okay. So for the question 2, we just factor it first to solve for its x-intercept. Oh no. So we just factor it first. Okay, so after we factor it, we can now solve it. So we have two solutions for this equation. X1 equals to -9, and X2 equals the +7. So these two values can both make the equation equal to the 0. And for the question 3, first we also gonna factor it in order to solve it. Okay, so we're gonna factor this stuff. Wait, that's -7. Okay. That's -13, so -10 and x plus 3. So we also come out with two solutions, +10 and -3. Okay. And for the fourth question, we're also gonna factor it in order to graph it. So no, sorry. One moment. X plus 1 times x plus 3. So we know that the x-intercept should be x equals to -1 and x equal to -3. So with those information, with this x-intercept and the y-intercept, which is +3, we can graph this equation. So give me a moment. So the equation should be like this. The x-intercept -3, -1, and the y-intercept +3. Something like this. Okay, so should I leave the last question to them? Okay. Then I think I'm done.
Okay, so please practice the last question by yourself. And then that's I think the only homework. And yeah, okay, let's stop sharing there. Okay. Janet, I think you can stop.